Hello and welcome to The Science of Sleep, where thoughts drift past galaxies and reality folds softly around imagination. Tonight, you don't need to solve anything or hold on to any details. Let your body settle. Let your mind float. Just picture this. You're lying in a hammock, but the sky above you isn't blue. It's velvet black. There's no moon, no sun, only a scattering of stars, glowing like quiet fires in the deep. And with a blink, you're no longer watching the sky. You're moving through it. Now, let me ask you something strange. Not how fast is fast, but this. What's the difference between speed and possibility? We talk about faster than light as if it's just a better car, as if it's just version 2.0 of fast. But it's not. Light speed isn't a speed limit, it's something we don't even fully understand. And still, we dream of breaking it. Because we want to go beyond. We want to touch the unreachable. Visit the other side of the stars before our tea gets cold. Call our future selves from Alpha Centauri. But here's the first paradox. The fastest things in the universe can't stop to say hello. They never age. They never arrive the way we do. And you? You're built from atoms that can barely cross the room before needing lunch. You are not made to go light speed. And yet, you want to. Tonight, you'll fall asleep on a spacecraft that doesn't yet exist. It hums with impossible power. The stars outside stretch into glimmering ribbons. Time feels slushy. Your thoughts float like jellyfish through quantum fields. And in this imagined place, this not yet, maybe, never place, you'll explore what it really means to want to move faster than light. But before we try to break the limit, let's sit with it for a moment. See, the speed of light isn't just a number on a science test. It's the frame around every canvas we can paint. About 300,000 kilometers per second. 8 minutes from the sun to you. More than 25,000 Earths stacked end to end every second. But more than that, it's the number that ties space and time together like two shoelaces in a knot. Twist one, the other tightens. Speed up, time slows down. Move through space faster, and space shrinks. Einstein showed us this wasn't just math, it was the fabric of reality. Which makes you wonder, how did we end up inside a universe with a speed? Think about it. Why should there be a cosmic limit to how fast one thing can talk to another? Why not just go faster? The answer, as with most things in physics, is because if you could, reality would stop making sense. Let me explain it with a cookie. Imagine someone tosses a cookie at you from across the room. You see it flying. You reach out. Crunch. Now imagine that cookie moved faster than light. By the time you reached out, you'd already eaten it yesterday. Or not at all. Or it hit you before it was thrown. Events break. Causality collapses. The whole movie of reality plays backward and forward and sideways all at once. But despite that, we still dream of doing it, of breaking the rule. Maybe it's because rules tempt us. Or maybe it's because somewhere deep inside our minds, we sense something about light speed that feels incomplete. Like the universe is showing us only part of the script. And every generation, every species that looks up and says, "What if?" tries to push a little further. From fire to wheels to rockets to radio waves to particle beams. From Newton to Einstein. From Mercury to the moon. But to go faster than light? That's not just an upgrade. That's not warp 10. That's tearing open the rules and asking, what else have you been hiding? So tonight, as you drift, you'll ride alongside that question. Not to answer it completely, that would be too easy. No, we'll do something more daring. We'll explore what happens when the question itself becomes the vehicle. Along the way, you'll meet photons that never age, particles that should exist but don't, bubbles of warped space, impossible energy, and one very judgmental paradox. We'll fold the edges of physics like paper, poke holes through time, and maybe, just maybe, whisper to the other side of the universe, even if it doesn't whisper back. So close your eyes, And remember this, you're not breaking anything, you're just peeking. And if you find this journey calming, curious, or just better than staring at the ceiling at 2 a.m., feel free to like, subscribe, or share this little dreamscape with someone else who wanders quietly. We've only just started. The stars don't blink out here. They just glow soft, silent, steady. You float among them, somewhere between thought and sleep, where time begins to stretch and meaning dissolves into sensation. And just ahead, always just ahead, travels the one thing that never seems to slow down. Light, not a metaphor, not a feeling. The real thing, a stream of photons, little messengers that never stop to rest, never need a nap, never question their path. They just go, and go, and go. But what does that even mean? What is the speed of light? You've heard the number before, 299,792,458 meters per second. Precise, proud, like a sign bolted into the universe itself. But that number, it's more than just speed. It's the rhythm of everything. You're moving through space right now, even lying still. Earth spins beneath you, orbits the sun, which itself drifts through the galaxy, wrapped in invisible arms of gravity and time. And through all this motion, light travels with no friction, no drag, no delay. Unlike you, it needs no starting line. It's already there. And maybe that's the hardest part to grasp. Not that light is fast, but that light defines what fast is. It's not racing against anything. It's the standard. It's the rule. It's the thing you compare everything else to. Imagine, just for a moment, that you're watching a beam of light leave a flashlight. You're holding it, pointing it forward, flying in a spaceship that's already zooming close to light speed. And then click, the beam still moves away from you, at the exact same speed. No matter how fast you're going, the light keeps its own pace. Never slower, never faster. It doesn't make sense if you try to imagine it like a car on a highway. But this isn't a car, this is reality, whispering a strange truth. The universe bends time and space just right, so that no matter who you are or how fast you're going, you always measure light at the same speed. And that's wild, because it means time, your heartbeat, your aging, your memories, can change depending on how fast you're moving. Because space, the distance between your hand and the stars, can stretch or shrink depending on who's looking, all to protect one rule. Light must always move at the same speed. And that's not just a cute quirk, it's the foundation of how GPS works. How satellites know where you are, why time moves differently for the astronauts up above than for the jogger on the sidewalk. Tiny differences, but real and constant. So when we say the speed of light is 299,792,458 meters per second, we're not just giving you trivia for a science test. We're handing you the heartbeat of causality, the thread that links one moment to the next, the signal that tells the universe what now even means. Light travels from the sun to your eyes in just over 8 minutes. That same light left the sun while you were still brushing your teeth, and now it's here, warming your face, dancing through leaves, reflected in puddles. But what's even stranger is what happens if you could travel with it, not just behind it, not catching up, but with it. You'd be timeless, frozen, stuck in an eternal moment, because for light, there is no ticking clock. From its perspective, if it has one, it goes from origin to destination instantly. It doesn't experience distance. It doesn't know time. And this is where your sleepy mind might begin to stretch just a little. Because if something can move without experiencing time or distance, what is movement, really? Is it just change? Or is it awareness of change? And if light can change location without change of self, what does that say about what it is? You feel the question rising in your chest, like a soft tide. But there's no need to chase it. No need to answer. Just let it swirl there. Let it settle like stardust. You are made of particles that once drifted through ancient stars, atoms fused in light, born in heat, now wrapped in skin. And here you are, wondering what it means to follow the thing that made you. Because light isn't just a measurement. It's the carrier of everything you see. It brings the world to your eyes. It draws shapes in the dark. It reveals the hidden. It paints color into your dreams. You don't see objects. You see the light reflected from them. The spoon in your kitchen, the leaf on your windowsill, the glow of a phone screen at midnight. It's all light, bouncing off surfaces, leaping across space, touching your eyes like tiny messengers whispering, "Look, look, look, look." So yes, the speed of light is a limit, but it's also a gift. It's the reason we see stars as they were. It's the delay that lets us wonder. It's the softness of distance that makes the universe feel enormous and still reachable. And maybe that's why we long to go faster. Not to defy light, but to meet it, to understand what it feels like to touch something the instant you think it. But tonight, you don't need to rush. You can drift here, wrapped in photons, carried on waves. Let the speed of light be your lullaby, precise, eternal, and still soft enough to fall asleep beside. Out here, the stars feel quieter somehow. You're drifting between galaxies now, where distances stop making sense, and even the silence feels stretched. Time doesn't tick, it exhales. And still, the question lingers gently at the edge of your thoughts. If light always travels the same speed, no matter how fast you're moving, then what does that mean for everything else? What happens when you try to catch it? A long time ago, not so long in the story of stars, but long in the story of humans, a man with soft eyes and a patient voice reshaped how the universe thinks. Einstein. He didn't shout. He didn't chase fame. He just followed a question no one else knew how to ask. He imagined a world where time wasn't a constant beat, but a ribbon that could stretch, twist, and fold. He pictured trains and clocks, lightning bolts and observers, and slowly, quietly, he built something radical. A truth too elegant to be loud. Relativity. It sounds complex when you first hear it, full of equations and tensors and curved geometries. But at its heart, it's simple. The rules don't change depending on who you are or how fast you're going. They adjust to keep the laws of physics the same for everyone. That includes light, but it also includes you. So imagine you're on a train, a very fast one, racing along at nearly the speed of light. You shine a flashlight forward. To someone standing on the platform, the beam races ahead at the speed of light. But to you, inside the train, the same beam does the exact same thing, no matter how fast the train goes. It seems impossible, unless time itself slows down to make it work. Unless space contracts. Unless reality reshapes itself ever so slightly, just to make sure that light keeps its rhythm. And that's exactly what happens. Time, that constant tick you feel in your pulse and breath, isn't actually constant. It bends. It softens. When you move fast, truly fast, your time slows down compared to someone standing still. It's not a trick. It's not a metaphor. It's real. Astronauts on the International Space Station, orbiting Earth at over 27,000 kilometers per hour, age just a tiny bit more slowly than you. Not enough to notice, but enough for physics to whisper, yes, this is true. So, if you could somehow ride a beam of light, you wouldn't just be going fast. You'd be stepping out of time, leaving behind the rhythms of your body, the decay of atoms, the flow of before and after. And that's where Einstein placed the brake. Because while time slows down for you as you accelerate, your mass increases. Not in the you need a bigger chair kind of way, but in terms of inertia, how much effort it takes to keep you moving. At light speed, your mass would become infinite. And to move something with infinite mass, you'd need infinite energy. And the universe, well, it doesn't hand out infinity like candy. So the faster you go, the harder it becomes to go just a little faster. It's like trying to run through honey, then syrup, then glass, then stone. This is not a punishment. It's a boundary written into the fabric of existence. Not a wall, but a curve. Not a no, but a gentle, maybe not like that. And yet, you keep drifting forward in this imaginary ship. Your engines hum quietly beneath you. You watch the stars slide past like melted pearls. And deep inside, there's a small, warm ache, because you still want to know. If you can't reach the speed of light, then where is your place in all this? The answer isn't in speed. It's in change. It's in the way your mind flexes to imagine these things. It's in the way you can float between galaxies with nothing but thought. It's in the way you, a fragile thing of cells and sleep and heartbeat, can stretch your awareness across time. And it's okay to feel small. You're allowed to drift. You're allowed to feel wonder. You're allowed to rest in the questions. Because physics isn't cold. It's not the enemy of magic. It is the magic, woven into the very idea of motion and stillness, time and memory, here and there. And somewhere in that magic, a quiet truth unfolds. We aren't supposed to break every rule. Sometimes we're meant to dance with them, to press gently against the edges, to ask what else might be possible, even if we never cross the line. So, let the speed of light be what it is, a guide, a whisper, a steady companion. You don't need to outrun it tonight. You can lie here, held by gravity and questions. You can let time stretch around you like a soft blanket, and know that you're already part of something beautiful. The laws of motion don't care if you sleep, but they'll be here when you wake. You're still floating. No effort, no direction, just drifting through a quiet field of stars, as if the universe has exhaled and you're caught inside the breath. There's no up, no down, no urgency, just motion without struggle. And somehow, even though everything seems still, you're moving, faster than anything you've ever known. But the faster you move, the more the world begins to change. Not outside inside. Your sense of time starts to bend, not in a dramatic way, but like the edge of a dream softening as it fades. Moments that once felt sharp now blur at the edges, like watercolor bleeding across a page. You try to grasp one, but it slips between your fingers. And this gentle warping of time has a name: time dilation. Not just a theory, but a quiet truth that unfolds only when speed becomes more than just motion. When it becomes transformation. Imagine riding in a spaceship that's approaching the speed of light. Not all at once, just slowly, gradually, as if the engines hum in sync with your heartbeat. Inside, everything feels normal. You sip tea, you blink slowly, you trace the condensation on the window. But if someone were watching you from far away, they'd see something different. They'd see you moving slower. Your hand would lift in syrupy time. Your tea would cool more slowly. Your blinking would become a gentle strobe. To them, your moments would stretch. But to you, it would all feel the same. Because the faster you move through space, the slower you move through time. It's not a trick. It's not a camera effect. It's how the universe keeps its balance. A kind of cosmic accounting where time and space trade responsibilities depending on how fast you choose to travel. And the effect isn't just imagination. We've measured it. Clocks flown on planes tick just a tiny bit differently than ones on the ground. Particles moving near light speed decay slower than they should. And astronauts aboard the ISS age just a little less than those waiting on Earth. Not enough to write home about, but enough for physics to smile quietly and say, yes, this is real. So what happens if you keep accelerating? If your ship keeps pushing forward, faster and faster, toward that unreachable barrier? Time slows more, distances shrink, and one day, if you somehow could reach the speed of light, your time would stop completely. From your perspective, everything would happen all at once. There would be no before or after, only a single, frozen instant stretched across eternity. But you can't reach that speed, because every time you push forward, the universe pushes back. Not with hands, not with force, but with resistance built into the very idea of movement. As you accelerate, your mass increases. Not visibly, not in weight, but in inertia, your resistance to change. It's as if the universe is gently saying, you can move fast, But if you want to move that fast, you'll need more than just energy. You'll need everything. To reach the speed of light, you'd need infinite energy. And even your wildest imagination doesn't stretch that far. But the idea still lives in your mind. Not because you think you'll break the rule, but because the edge of that rule tells you something about the shape of reality. It says that time isn't fixed. That motion isn't just distance divided by time. That when you move fast enough, you stop being just a traveler. You become a part of the universe's deeper rhythm. And maybe that's why we find time dilation so strange. Because it suggests that time isn't something you move through. It's something that moves with you. It wraps around your motion. It responds to your choices. Like a dance partner. And even here, drifting in your imagined ship, you feel it. A quiet pull, not from the engines, not from gravity, but from the idea that your presence, your speed can shape time itself. You're not a passenger in the universe. You're part of its fabric. Every breath, every blink, every heartbeat weaves your thread into the greater tapestry. And as you move, the weave shifts, flexes, stretches gently to accommodate you. So if you ever feel rushed, if the clocks around you seem too loud, too fast, too sharp, remember this. Time isn't a tyrant. It's not a ticking threat. It's a companion. It bends for you. It slows when you move and waits when you dream. Tonight, it's already doing that. You've slipped from second to second without noticing. Your breath has become slower. Your thoughts have softened. Your awareness is suspended in a kind of still motion. That's time dilation too. Not from speed, but from peace. Because there's another kind of motion, not through space, but through stillness. And here, in this quiet moment, you are traveling farther than light ever could. Let it stretch. Let it hold you. You're exactly where you need to be. There's something strange happening now. You've been drifting for a while, quiet, suspended in the hush between stars, but something has shifted. It's not loud, it's not sharp, just a subtle weight pressing in, not around you but within. The ship, still gliding effortlessly in your mind, begins to press forward with more urgency, as if drawn by some invisible goal just beyond the edge of vision. And you begin to feel it. Not fear, but resistance. Not in the engines, in yourself. It's harder to move now, not because of space, or friction, or obstacles in your path, but because with every increase in speed, something within you seems to become heavier, more difficult to shift, like dragging your thoughts through molasses, like moving in a dream where your legs no longer obey. This isn't metaphor. It's the quiet truth of mass, a truth Einstein saw, sitting alone in his mind, while the rest of the world still thought of time as absolute and motion as simple. As you approach the speed of light, just approach, your mass increases. It's not a trick of gravity or a change in shape. It's a deep response built into the universe's design. Your body, your ship, your atoms, they begin to resist acceleration not because they're stubborn, but because motion itself demands more and more energy the faster you go. Not linearly, exponentially. A small push gives you a little speed. Another push gives you a bit more. But soon each new push offers almost nothing in return. You burn more and more energy just to gain an inch. Crawl. A whisper of motion. And the reason is simple, though not easy. Mass and energy aren't just connected. They are the same. Two names for the same thing, dancing in different outfits. You've heard the equation before. E 等于 mc². Three symbols that hold the entire rhythm of the cosmos. It means that mass can become energy. Energy can become mass. And both, when pushed hard enough, reveal just how deeply they are woven into the structure of space and time. So when you try to go faster, you're not just pushing through empty space. You're asking your own mass to cooperate. But it doesn't. Not easily. It grows. It resists. It begins to ask for more than you can give. And as you get closer and closer to the speed of light, that demand becomes infinite. Not just inconvenient, not just expensive, infinite, which means you'll never get there. Not because the engines fail, not because the stars forbid it, But because to travel at light speed, you would need to become light, massless, timeless, weightless in the most literal sense. And you are not. You are made of particles that have mass, quarks and electrons, atoms and molecules. You occupy space. You experience time. You grow and change and remember. And those are beautiful things. They are what allow you to love, to feel, to age, to sleep. They are what make this moment, this quiet, floating possible. If you were massless, you would never stop to see the stars. You would never pause to listen. You would not know what it means to wait, or to rest. And maybe that's what makes the speed of light such an exquisite boundary. It's not a punishment. It's a blessing in disguise. A quiet way the universe says, you get to be. Because motion without time is not experience. It is silence, frozen and eternal. And as much as you long to travel far, you are also here to notice the journey. So you let go of the need to accelerate. You loosen your grip on that invisible throttle. You settle again into the seat of this imaginary ship and feel the way the universe holds you not with force, but with rhythm. A pulse of light, a breath of gravity, a hum of mass. Everything moves, but everything resists. And that resistance isn't a flaw. It's what gives motion meaning. Even here, even now, without any engines, you can feel it. The slow drift of thought, the deepening of your breath, the subtle way your limbs sink into the bed beneath you, your body growing heavier, not because of gravity, but because you're letting go. This is another kind of inertia, a kind that welcomes stillness. So maybe the universe isn't asking you to go faster. Maybe it's asking you to feel the weight, to appreciate the resistance, to rest in the slowness that gives light its contrast, and speed its wonder. You don't need to reach the limit to touch it. You've already arrived at the edge, and you're still here, still breathing, still glowing, like a quiet star on your own slow path through space. Let yourself drift. There is no rush. Even light takes its time. The stars have begun to blur again, but not because you're moving faster, no. It's something gentler, like the edges of your awareness softening, stretching, drifting just beyond sharp focus. You're not lost. You're dissolving slightly into stillness, and through that calm something glides past you, quiet, constant, and untouched by everything else. Light. It moves on its own terms, not because it's fast, but because it's free. Free from mass, free from time, free from resistance. It is not weighed down like you are. It doesn't need fuel or rest. It simply goes, because that's what light does. And maybe that's the real mystery. It's not how fast light is. It's how little it's affected by everything else. You, made of cells and bone and thoughts that change with every heartbeat, respond to force and friction. Light does not. You slow down. Light never does. That's because light has no mass. Zero. Nothing. Not even a whisper of weight. It is not a thing you can hold. It's not a little marble zipping through the dark. It's a ripple, a wave, a particle sometimes, a duality always. Photons, the particles of light, aren't like little bullets. They're more like messengers that don't remember where they came from and never stop to wonder where they're going. They don't experience time. They don't decay. They can't be at rest. If you could somehow become one, if you could strip away all your mass and ride a photon like a surfer rides a wave, you wouldn't age. You wouldn't experience movement. From your point of view, the moment you leave is the moment you arrive. Everything in between collapses into now. It's not just a poetic idea. It's a physical truth. For light, there is no during. There's only is. And because it has no mass, light isn't affected by what slows everything else down. No inertia. No drag, no resistance. That's why it can travel at exactly the same speed forever. Through galaxies, through vacuums, through you. Yes, even through you. Right now, as you lie still, drifting in your thoughts, light from distant stars is passing through your body, through your skin, through the gaps in your atoms, through the dark, quiet spaces that make up most of what you are. and yet you feel solid. Still, real. But most of you isn't. You're made of atoms, yes, billions and billions of them. But atoms are mostly empty space. And through that space, light walks like a ghost. That's how it sees the universe, not in boundaries, but in transparencies. It bends around stars, curves through gravity, dances across magnetic fields. It isn't blocked so much as it chooses what to notice. Even when it is stopped, like when it hits a mirror or gets absorbed by a leaf, it's only because it allowed itself to, only because it exchanged its energy, only because it gave something to the matter that caught it. And in that moment, it disappears. Not dies, just becomes something else. Heat, motion, growth. A photon absorbed is never wasted. It simply continues in a different form. Maybe that's a lesson too. Not everything needs to keep moving forever. Sometimes, offering your light to something else is the movement. Sometimes, resting is transformation. The more you learn about light, the less solid it becomes. It's not a beam. It's not a point. It's a probability. A ripple of possibility across space and time. Quantum physics tells us that until light is observed, it doesn't even choose a path. It travels all paths. It interferes with itself. It arrives in all the ways it possibly could. And only when you look, only when you measure, does it commit to one. So light doesn't just move. It decides. Or perhaps it's better to say it waits for you to decide. And now, in this moment, as you lie still and the weight of the day slides off your body, you are surrounded by light that has traveled across billions of years to touch you. Light from stars that died before humans ever stood upright. Light from galaxies whose names you'll never know. Light from the birth of everything. And you don't have to do anything with it. Just receive it. Let it pass through. Let it warm some quiet part of your mind that doesn't need words. You don't have to be fast. You don't have to be massless. You don't have to outrun the laws of nature, because you are already part of them. A little slower, a little heavier, but no less beautiful. And maybe that's why we can see light, but never touch it. Because it's not meant to be captured. It's meant to be followed. Not with speed, with wonder. And tonight, you've already followed it far enough. Let it drift on. Let it hum quietly in the space around your thoughts. And let yourself slow down. You are not a photon. You are something better. You are the one who dreams about them. There's a soft stillness now, the kind that only comes when your thoughts begin to trust the quiet. You're not falling asleep. You're floating into it, without effort, without needing to hold on to anything. And while your body sinks deeper into rest, your mind drifts gently toward a different kind of question. If light always moves the same speed, and if you can never catch it, then what, exactly, is stopping you? There's no wall, no glowing red line painted across the stars that says, "Do not pass." No sirens, no cosmic traffic cop whistling at your ship. And yet, there's something that holds you back, not with force, but with math. Because the universe doesn't yell, it whispers in equations. To go faster than light, you'd need more energy than exists. To send a signal faster than light, you'd need to play tricks with time. To outrun a beam of light, you'd have to break causality itself. Causality, one thing leading to another. A cup falls, and then it breaks. A fire burns, and then there's smoke. You speak, and then someone hears. It's not just a human idea. It's the logic holding the universe together. And the speed of light is what protects it. Because when you can't exceed light speed, you can't send effects ahead of causes. You can't undo events by outpacing them. You can't receive a message before it's sent. Everything stays in order quietly, invisibly, obediently. But it gets stranger, because the speed of light isn't just about movement. It's about information. It's about the maximum speed at which anything, a thought, a particle, a signal, a heartbeat, can influence anything else. You're not just bound by how fast you can travel, you're bound by how fast change can travel. If something were to move faster than light, it wouldn't just be fast. It would be breaking the order of events. It would mean someone in the future could whisper into the past. It would mean you could see an explosion before it happened, react to something before it existed. And the math quiet, consistent, careful says no. That's not how this works. You can't break that rule without unraveling everything else. Still, you wonder, could there be a loophole? Maybe not through light, but around it. Maybe the universe doesn't need to shout the answer. Maybe it's hidden in curvature, in folds and shadows and shapes you haven't yet imagined. Because when Einstein described space-time, he didn't describe a flat surface. He described a fabric, flexible, stretchable, able to bend under mass and gravity and motion. And that's where the mystery deepens. Because if space and time can bend, maybe they can be reshaped, not broken, not ignored, but curved just right. Imagine a piece of paper with 2 dots on it, 2 distant stars. Draw a straight line, and it takes time to travel, but fold the paper until the dots touch, and suddenly the distance disappears. Could the universe work like that? Could you travel vast cosmic distances without moving through space at all? Not by speeding up, but by bending space itself? That idea, the gentle folding of reality, will come soon, and with it, a dream called the warp drive. But for now, you're still drifting here in the soft tension of limits. And limits, oddly enough, can be comforting. They remind you that there's structure, that the universe isn't chaos, that rules exist and they hold. Like the gentle edge of sleep, they tell you where you end and something else begins. And in that boundary, there's safety, there's order, there's calm. You may not be able to go faster than light, but you can still reach beyond it with questions, with thought, with dreams that fold time without needing to travel through it. Because even if physics says no, your imagination whispers otherwise. And sometimes, that's enough. You feel it now, a slowing in your breath, a softening in your chest, a loosening of something behind your eyes. You've reached no destination, but you've moved, not through distance, through understanding, through stillness. And the truth is, that's what makes you different from light. It always moves, but it never rests. You, on the other hand, you get to pause. You get to feel the moment slow. You get to ask questions that don't need answers tonight. Like, if nothing can go faster than light, then why do your thoughts keep slipping ahead of it? Maybe because dreams have their own kind of speed, and tonight, you're already ahead. You're somewhere between stars now, but also somewhere between thoughts. It's the kind of stillness that doesn't ask for anything, just lets you be. And in that soft space, something flickers across your imagination, not a ship, not a star, but a word, a whisper, really. Tachyon. It sounds like fiction. Feels like it belongs in a comic book or a late-night sci-fi movie, where someone shouts, "Reverse the polarity." But the idea behind it, it's very real. Not proven, not observed, but real enough to live inside physics as a question we haven't answered yet. Tachyons are theoretical particles. Not slow ones, not even fast ones. They are particles that, if they exist, would always move faster than light. Not sometimes, not briefly, always. Unlike you, they couldn't slow down, couldn't rest, couldn't stop to take in the view. They would live in a reversed universe where speed increases as energy decreases, where time might run sideways or backward or in patterns that make clocks feel embarrassed. It's not that we've seen them. We haven't, not once. But when scientists solve certain equations, sometimes these ghost-like particles show up in the math, peeking around the edges, suggesting possibilities we're not sure how to live with. And even though no one's caught one, we keep them in the margins, not because we think they'll show up in a jar tomorrow, but because they ask something interesting. What if something could go faster than light? What would it feel like? What would it see? If you could somehow become a tachyon, you wouldn't speed up to light speed, you'd start beyond it, and slowing down would be impossible. To you, time wouldn't make sense. The arrow of cause and effect would bend or splinter. You might arrive before you left. You might remember things that haven't happened yet. You might exist as a ripple in someone else's timeline, present, but only barely. And this isn't just imagination. It's a serious part of how we explore the edges of theory. A way to ask, is the speed of light a ceiling or a mirror? Because when you imagine tachyons, you're not really hoping to meet one. You're hoping to understand something deeper, the nature of limits, and what it means to press against them. Tachyons remind us that the universe is stranger than any story. They aren't rebels, they're reflections. They live in the space between what we know and what we dare to imagine. And maybe they'll never be real. Maybe they're just a side effect of math, like a dream your brain had while solving a puzzle. But dreams can still teach us something. They show us that even in science, especially in science, there's room for the impossible. Room for curiosity that doesn't have to be right, just sincere. That's what keeps the work alive, not the answers, the wondering. And as you drift here now, between one breath and the next, you start to realize maybe that's what you've been doing all along. You've never needed to chase the speed of light. You've been chasing the edge of understanding, not to conquer it, just to reach it, touch it, and listen for the soft echo it sends back. The universe doesn't mind your questions. It was made to hold them. So even if tachyons never flash across a screen, even if they stay forever in the realm of what if, they've already done their job. They've given you a place to rest your curiosity. They've said, here's a window you can't open, but you can still look. And isn't that enough? You don't need everything to be proven. Sometimes it's the unprovable things, the ones just outside the reach of light, that bring the most peace. Because they remind you how vast this dream really is, how much space there is to explore, how many ideas can live in the quiet just beyond certainty. Let the tachyons drift back into the shadows now. They were never here to stay. Just passing thoughts, fast, strange, and fleeting, like the ones that visit your mind right before sleep. You're slowing down again, not to stop, just to settle, to find that soft rhythm where time doesn't need to move at all. Because while the universe rushes forward, you get to rest. You're not moving anymore, or at least it doesn't feel like you are. There's no hum of engines, no flicker of lights passing by, just quiet, like the silence between thoughts. And yet, even in this stillness, you imagine something strange. What if you could ride a beam of light? Not follow it, not chase it, but become part of it. Cling to it like a child holding onto a kite string, gliding through space on something so pure, so constant, it doesn't even feel like motion anymore. It's a soft idea, and a gentle one, but it opens a door, because to ride a beam of light is to let go of everything you've ever trusted about how the world works. There's no more before or after, no distance, no time. You wouldn't be traveling through space. You'd be skipping over it entirely. From your point of view, the moment you leave is the same moment you arrive. Whether your destination is a meter away or a million light years, it's all now. And that's hard to imagine, because you've never known life without time. You wake, you move, you grow. Your heart ticks in quiet rhythm. Your days stack gently, one on top of another, until they form something you call memory. But light knows none of that. A photon, the tiniest particle of light, is born and gone in the same breath. It leaves a star and touches your eye with no experience in between. It doesn't age. It doesn't pause. It simply is. And yet, somehow, it carries everything. Color, warmth, information. It brings you the past, the glow of stars long gone, the shape of galaxies whose light took billions of years to reach you. You don't see things as they are. You see them as they were when their light began the journey. And if you could ride that beam, what would you witness? Would you watch the universe stretch behind you? Would you see space melt into something flat, like ink spread too thin across a page? You wouldn't feel speed, because speed is measured against time. And for you, now light speed, time has stopped playing along. That's the puzzle. Light moves through time from our view, but it doesn't experience it. To us, the trip takes years. To the photon, the trip doesn't even happen. It has no clock, no delay, no awareness of the space it's crossed. It simply touches what it was always meant to touch. And maybe there's something beautiful in that. A kind of trust, because light never questions where it's going. It just goes. No hesitation, no doubt, no ego. But you are not light. You carry mass. You carry memory. You carry the weight of wanting to understand. And still, you wonder, what if? What if I could live without the waiting? What if I could be there? Without the years? Without the miles? Not for convenience, but for connection. To reach someone you love across a galaxy. To step onto a world where no one has ever been. To see the edge of creation. Not eventually, but now. These aren't selfish questions. They're human, and that's what makes them powerful. You see, it's not the speed of light that defines us. It's the longing for what lies beyond it. Even now, lying still, you are moving in thought. Not fast, but far. Far enough to picture riding a wave that knows no time. Far enough to feel what it means to let go of sequence. Of minutes and hours. Of beginning and end. And, even though it may never happen, even though you may never become a beam of light, the imagining itself is its own kind of travel. Because there's another kind of light, not the kind that passes through vacuum, but the kind that passes through you. The light of wandering, of reaching, of dreaming beyond what is given. And maybe that's why photons matter so much. Not because they move, but because they remind us how much we wish to. So no, you can't ride a beam of light. Your body is too heavy. Your clock too real. Your heartbeat too soft. But your mind has already left. It's already touching the stars. It's already arrived in places your feet may never go. And that's enough for tonight. Let the light keep moving. Let it pass gently through the spaces between your thoughts. Let it settle over you like a second skin, warm, patient, eternal, and let yourself become still again. Because even if you can't move at the speed of light, you can rest in its glow. Somewhere in the vast ocean of silence, you begin to wonder if the speed of light is a wall. Is there a way to move without crossing it? Not by breaking it, not by going faster, but by doing something gentler, something more clever. What if, instead of racing through space, you brought the destination to you? That idea, as delicate as it seems, is what led physicists to imagine something called a warp drive. Not the kind with blinking buttons and sci-fi sound effects, but a real solution tucked inside Einstein's own equations. It's called the Alcubierre drive. And though it exists only in theory, it offers something astonishing. A loophole, not by speeding up the ship, but by bending the very fabric of space around it. Imagine a blanket stretched flat, your ship sitting calmly on it. Now, imagine folding that blanket so that two distant points touch. The ship hasn't moved at all, but suddenly it's somewhere new. No acceleration, no violation, just a clever rearrangement of space itself. The warp drive does exactly that, at least in the math. It doesn't push the ship faster than light. Instead, it contracts space in front of the ship and expands it behind. The ship floats inside a bubble, like a leaf caught in a gentle stream, carried forward not by force, but by the shifting current of space itself. And this is where things get strange in the quietest way. Because space isn't just emptiness. It's a fabric flexible, stretchable, and sensitive to mass and energy. Einstein showed that gravity isn't a force pulling things together, but a curve in that fabric, guiding things along bent paths. The moon orbits Earth, not because it's being pulled, but because Earth's presence warps space, and the moon is simply following the curve. So if space can bend around mass, maybe, just maybe, it can be shaped in other ways too. If we could learn how to curve space like paper, to compress it like memory, we wouldn't need to travel faster than light. We could simply take a shortcut through space itself. The Alcubierre drive describes a way to do that. It's precise. It's consistent with general relativity. It even predicts how much energy you'd need. And here's the catch, it's a lot. Not regular energy, either. It requires something called negative energy, a kind of exotic matter that we've never seen but that shows up in certain quantum theories. The kind of thing that feels less like fuel and more like science whispering, "I'm not sure this should exist." Without that negative energy, the warp bubble can't form, and even if it could, keeping it stable would be like balancing a marble on a needle during an earthquake. Still, the equations don't forbid it, and that fact alone is enough to stir the imagination. Because the warp drive isn't just a concept, it's a question. It asks whether speed is really the issue, or if our understanding of space is still too narrow. It suggests that maybe the path forward isn't in building better engines, but in understanding the stage we're traveling on. Not the ship, but the sea. And that makes you think maybe some of the limits we face aren't about force. Maybe they're about form. Maybe space, like time, isn't fixed. Maybe it's something you can shape gently, like breath in cold air. And maybe that shaping is what travel will become. So tonight, in this stillness, let yourself drift with that idea. Let go of the need to move faster. Let your mind feel the soft give of space itself, the quiet suggestion that the road might one day move for you, that the universe, instead of resisting your motion, might one day learn to fold itself in ways that bring the distant near. You don't need to understand all the math. You don't need to memorize the metrics of a warp bubble or calculate the quantum fields. You only need to know that the rules of the universe, while firm, are also flexible, and that somewhere in those quiet curves, new paths may one day unfold. Tonight, you are already inside one, a bubble of thought, a soft field of curiosity carrying you forward without effort. No resistance, no noise, just motionless motion. And though you haven't moved an inch, you've traveled far. Rest there. Let the bubble hold. Let the stars shift gently, not because you're chasing them, but because you're ready to receive them. The idea still lingers, the image of a ship gliding through space, without moving at all, gently wrapped in a bubble of curved geometry. You haven't let it go. Not because you expect it to happen soon, but because it feels right, in a strange, quiet way. As if the universe could have hidden shortcuts, not out of secrecy, but because we weren't calm enough to notice them yet. This warp bubble, this floating pocket of space that carries you forward, doesn't work like anything else you know. It's not thrust or propulsion or momentum. It's not about pushing harder. It's about reshaping the road beneath you. And at the center of it all lies one deeply unsettling requirement, something called negative mass. It's not something you've ever touched. It doesn't sit in batteries or glow inside stars. It's a concept more than a substance, a placeholder for the kind of physics we haven't grown into yet. Negative energy. Matter that doesn't just pull, but repels. Something that falls up instead of down, that slips away from pressure instead of yielding to it. In the equations for the Alcubierre drive, this negative energy is what makes the bubble work. Without it, the space in front of the ship can't be compressed, and the space behind can't expand. The bubble never forms. The fabric stays flat, the shortcut stays folded, and suddenly the dream collapses. But the strange thing is, this kind of energy isn't purely imaginary. In quantum mechanics, there's a phenomenon called the Casimir effect, where two metal plates placed extremely close together in a vacuum experience a tiny force drawing them together, not because of heat, not because of pressure, but because the space between them has slightly less energy than the space around them. It's as if empty space isn't empty at all, but constantly boiling with invisible particles that flash in and out of existence, cancelling each other out like whispers in the dark. And between the plates, fewer of those fluctuations can exist. Less noise, less energy, almost negative. It's a small effect, very small, measured in laboratories with instruments more sensitive than anything your senses could understand, but it's real. It hints at the possibility that negative energy, whatever that truly means, might not be completely forbidden. It might just be rare, elusive, a flicker at the edge of what's possible. And yet, building a warp drive wouldn't require a flicker. It would require oceans of it. enough to curve space-time, hold a stable bubble, carry a ship, and not collapse the moment you looked away. It's the difference between catching a breeze and trying to trap the wind in a bottle. Physicists debate whether it's even theoretically feasible. Some say the energy requirements are so absurd that they break the point. Others say we haven't found the right configuration yet, that a more efficient version might be possible someday. A version that bends rather than breaks what we understand. And so, the warp drive remains in limbo, not false, not true, just suspended in possibility, like a bridge you can almost see through the mist. That's the nature of physics at the edge. It's not a wall, it's a horizon. And maybe that's why it continues to capture imagination. Not because it's close, but because it offers something more than travel. It offers hope, the idea that the distant might become reachable, that the universe might not be limited to what we already know how to do, that the stars aren't so far. After all, they're just waiting for a new kind of movement. Not one of force, but of understanding. That's what makes the idea of the warp bubble so soft and compelling. It doesn't fight nature, it asks permission. It doesn't break rules, it finds the edge of them and listens. It suggests that maybe the universe wants to be discovered, but gently. That it opens only to those willing to sit with the questions instead of forcing answers. And that feels human. Because isn't that what you're doing now? Sitting quietly with something you can't quite grasp. Letting the thoughts stretch you, not to win, not to finish, but simply to grow. There's a kind of travel in that too. A motion through wonder. So let the warp bubble remain where it is hovering, in theory, carried on equations, glowing faintly in thought. Let it drift through the background of your mind, not as a blueprint, but as a lullaby. A soft refrain that says, even when the road looks fixed, there may still be ways to fold it. Tonight, you're not chasing the stars, you're inviting them closer. Let them arrive in their own time, just as you are. You've been thinking about impossible things for a while now, riding light, bending space, drifting inside bubbles that reshape the universe, and somehow it doesn't feel strange anymore. It feels natural, like the way silence feels natural when it lasts just long enough. Your thoughts no longer reach forward with urgency. They float, softly, like paper boats set adrift on still water. And here, in this quiet state, you return to something small, something often overlooked, a gap between metal plates, a flicker in a vacuum, a force that shouldn't exist, but does. The Casimir effect. It's not loud. It doesn't announce itself like a comet or roar like a rocket. It's subtle, almost shy, but its existence hints at something profound, that even nothing isn't truly empty. Picture two smooth, flat metal plates placed very, very close together, so close you couldn't slip a virus between them. No atoms, no particles, nothing in between, or so it seems. But the quantum world doesn't tolerate nothing. The vacuum, as we call it, teems with energy particles flashing in and out of existence, not stable, not permanent, but real enough to nudge the plates ever so slightly toward each other. A pressure from nowhere, a force from nothing. And yet, this force can be measured, delicately, precisely, like a whisper that leaves fingerprints. It's not strong, but it's undeniable. Proof that even in silence, there's a kind of hum. What's so beautiful about this effect is that it challenges what we mean by empty. Because if the vacuum has energy, if even nothing is something, then space itself is not neutral. It's alive with potential. This is where the idea of negative energy begins to feel less like a fantasy and more like a mystery we simply haven't learned how to unwrap. Because within this vacuum energy, within these tiny quantum fluctuations, lies the closest thing we've ever found to the exotic material a warp bubble would need. The Casimir effect doesn't give us a warp drive, but it opens a door. It shows that the universe has more to say than we thought, that the silence between atoms isn't silent at all, that space isn't passive. It participates, and maybe, just maybe, we can learn to shape it. Physicists have long speculated that if we could harness these quantum fluctuations, guide them, stretch them, intensify them, we might be able to generate negative energy, enough to hold open a wormhole, enough to stabilize a warp field, enough to send a ship drifting quietly through curved space, never breaking the speed of light, but still arriving faster than light would. It's still a long way off, maybe impossible, maybe not. Scientists still debate whether negative energy can exist in large amounts without unraveling the stability of space-time itself. Some believe it could lead to paradoxes or singularities. Others think it may one day become a real part of technology. For now, it lives in the gentle overlap between science and speculation. But even if it stays there, it serves a purpose. It reminds you that the universe is filled with quiet possibilities, that the things we once considered empty often carry the seeds of something more, that just because something hasn't happened yet doesn't mean it can't begin in a whisper. And isn't that what you're doing now? Lying still, listening, resting in the hum beneath the silence, opening just enough space between thoughts to feel something shift small but real. You don't need to master quantum field theory to appreciate this. You don't need to calculate the energy density of the vacuum or design nanoscale plates in a lab. You just need to know that possibility exists, that even in the smallest corners of the universe something stirs. That's what the Casimir effect shows us, that the fabric of reality is never flat, never inert, that space itself has texture, tension, response. It breathes with you. And if the vacuum holds energy, then stillness holds motion. Then even your rest tonight is part of something larger. So stay where you are. Let the silence deepen. Let the space around you feel just a little more alive. You don't have to touch the stars to know they're reaching too. You don't have to chase the future. You're already inside it, gently, without effort. Let your breath soften. Let your thoughts dim. The vacuum doesn't need to be filled. It only needs to be noticed. And in doing that, you've already arrived. You've been gliding quietly for some time now, not through distance, but through ideas. One by one, they've opened before you like doorways without walls, warp drives, photons, negative energy, all mysterious, all possible, and all still just out of reach. But now another thought drifts into view, gentle and strange. What if there's already a shortcut? What if, instead of folding space, something in the universe has already poked holes through it? Wormholes. They sound fictional, don't they? Like plot devices in movies where characters leap from one galaxy to another in a heartbeat. But here's the curious thing. Wormholes aren't fiction, not entirely. They appear in Einstein's equations as natural possibilities, mathematical tunnels that could, in theory, connect distant regions of space-time, like bridges between faraway shores. Imagine you're holding a sheet of paper. Draw two dots far apart, one near the top corner, one at the bottom. That's how we usually move through space, across the page, along the surface. But now fold the paper so those two dots touch. Suddenly, the distance disappears. That's the logic behind a wormhole not moving faster, just skipping the space between. In theory, a wormhole could allow you to enter one place in the universe and exit somewhere unimaginably far away, without ever traveling through the space in between. And because it connects 2 points in space-time, not just space, it could under the right conditions link different times as well. The idea is elegant, mysterious, quietly thrilling. But the reality is more fragile. The first problem is stability. A wormhole, if one could form, would collapse almost immediately. It wouldn't stay open long enough for even a single atom to pass through. To prevent this, scientists propose the use of exotic matter again, with negative energy to hold the tunnel open. But just like the warp bubble, this exotic matter remains elusive, theoretical, shimmering at the edge of our understanding. And then there's the second problem, paradox. If a wormhole allows you to travel from one point in time to another, what happens if you interfere with your own past? What if you arrive before you left? These are more than science fiction questions. They're real puzzles that tie physicists in knots. Some believe the universe has built-in safeguards, rules we don't yet see, that would prevent contradictions from forming. Others think wormholes, if they exist, must be carefully limited to avoid temporal chaos. And yet, despite all these complications, the idea remains. Not because we've seen a wormhole or built one, but because the mathematics allows it. Because the universe, for all its silence, has written a kind of possibility into its structure. And we, small and curious as we are, continue to follow the trail. There are even hints, subtle, indirect, that wormholes might leave signatures in the fabric of space. Unusual gravitational effects, the way light bends and travels across great distances. Nothing definitive, but enough to keep the conversation alive. And sometimes, that's all an idea needs. What's remarkable is how the concept has grown not just in physics, but in imagination, in books, films, dreams, in late-night thoughts like yours. Because wormholes don't just offer a way to travel quickly, they offer a kind of comfort, a whisper that distance isn't absolute, that separation might be an illusion, that the things you love, the people you miss, the places that seem forever beyond reach, maybe they're closer than you think. Maybe space isn't a prison. Maybe it's a puzzle, and puzzles are meant to be solved. So, as you lie there now, breathing gently, you can imagine one of these tunnels opening quietly in the dark. No noise, no explosion, just a subtle shifting of space around you, like a curtain lifting in the wind. On the other side, a distant star, or a memory, or some quiet version of you, resting under a different sky. The wormhole doesn't need to be real for the image to be powerful. It just needs to be possible. Because possibility is what keeps us dreaming. It's what lets you explore places your feet will never touch. And sometimes, the simple act of imagining a path is the first step toward finding one. So let the thought pass through you like a ripple. Let it settle. You're not trying to escape reality. You're trying to listen more closely to what it's saying. And tonight, it's saying that the distance between things isn't always what it seems. The idea of wormholes has drifted with you through sleep and thought, but now a quieter, more unsettling question begins to rise. If something could move faster than light, whether through a tunnel, a bubble, or a ripple in space, what would that really mean for time? Not for clocks or schedules, but for cause and effect, for memory, for the gentle line your life follows from one moment to the next. Because here's where things get complicated. Faster than light travel doesn't just bend space. It bends time, and when you bend time far enough, it stops behaving the way you expect it to. It loops. It folds. It invites paradox. Imagine this. You build a ship that can cross galaxies in a heartbeat. You fly to a distant star, send a signal back to Earth, and the signal arrives before you left. Suddenly, people are receiving information before it's sent. Conversations begin before they're spoken. Events respond to things that haven't happened yet. It sounds playful at first, a puzzle, but then you realize what's at stake. The basic sequence of everything starts to blur. The simple rule that says, first this, then that, no longer holds. And once cause and effect unravel, so does meaning. If a message arrives before it's written, who wrote it? If an event causes itself, did it ever really happen? These aren't just abstract problems, they cut into the fabric of reality. They turn history into loops. They make free will murky. They unsettle the very idea of consequence. This is where physicists begin to disagree. Some believe the universe simply won't allow such things, that there are hidden rules still undiscovered that keep causality safe. Others argue that paradoxes, while strange, might be self-healing, that even if time loops exist, they somehow protect themselves from contradiction. One idea is called the Novikov self-consistency principle. It suggests that even if time travel or faster than light communication is possible, events will always unfold in a way that prevents paradox. You can go back, but you can't change what's already happened. You might think you have a choice, but the timeline gently guides you back into alignment, like water finding the path of least resistance. Still, it feels fragile, doesn't it? As if the universe is balancing on the edge of something. As if every rule we know is built on trust, that time will move forward, that messages will follow thought, that tomorrow won't arrive before today ends. And so, maybe that's why light speed holds firm. Not just because it's fast, not just because of energy or mass, but because it's a boundary that protects the story from falling apart. It keeps time in order. It preserves the rhythm of experience. You can almost feel that rhythm now, a slow pulse under your breath, a sequence, one moment gently cradling the next, the warmth of memory, the anticipation of dreams, all of it carried by the simple comfort that now is now, and what comes after has not arrived. And maybe that's the real reason faster than light travel remains unreachable. Because it's not just about going far, it's about keeping the music intact. A melody that needs its notes to follow one another. A journey that only makes sense when the steps come in order. Still, the temptation remains. To reach beyond, to send messages faster than thought, to peek ahead, to fix the past, to connect with people, places, or versions of ourselves that seem impossibly far away. That desire is deeply human, and maybe that's okay. But for tonight, you don't need to outpace time. You can stay here, where cause and effect remain whole, where dreams follow breath, and thought follows feeling, where each moment arrives, exactly when it's meant to. The stars above are still watching. Light continues its journey, slow and perfect. And you drifting now, gently, with eyes half closed, are exactly where you belong, safely nestled in the rhythm that holds everything together. There's nothing to change, nothing to fix, just the steady comfort of time moving forward, one heartbeat at a time. The quiet is deeper now, not from silence, but from understanding. The kind of stillness that comes when questions no longer need immediate answers. You've floated alongside light, curved space, peeked through the idea of wormholes, and now you're resting just on the edge of something even more delicate, something that whispers rather than announces. Quantum entanglement. It's called spooky action at a distance, a phrase Einstein used with a mix of curiosity and discomfort, because even he who helped us understand the fabric of space and time was unsettled by what quantum mechanics suggested, that two particles, even when separated by vast distances, could remain connected in a way that defies the logic of everything we've seen in the larger world. Imagine two particles created together entangled. They spin, not like wheels, but like tiny probabilities, undefined, until someone observes them. Measure one, and its twin miles away, or even light years away, snaps into its own corresponding state, instantly. No delay, no signal passing through the space between, as if they were never truly apart. You want to say that something must be moving between them, some secret message, some tiny spark of communication. But again and again, experiments show nothing travels. And yet, something changes, like a shared breath between distant twins, like two leaves on different trees trembling in the same wind. This feels like faster than light behavior. It feels like breaking the rules, but it isn't, not exactly. Because although entanglement is instantaneous, it doesn't allow you to send messages. You can't control the outcome of a quantum measurement. You can't use it to transmit a thought or a warning or a love letter across the galaxy. It's like two dice that always roll opposite numbers. You roll a 6, and without even touching it, the other rolls a 1. But you didn't choose the 6. You only saw it. The connection is there, but it's silent. It speaks no language. It can't carry information, only correlation. And so, while entanglement suggests a kind of hidden unity in the universe, it doesn't offer a shortcut for travel or talk. It's a window, not a bridge. It shows you that space is not as separate as it seems, that distance may be an illusion at the smallest scale, but it doesn't let you jump ahead. Still, that quiet connection, it stirs something, because it feels so different from the way we experience the world. We believe in here and there, in cause and effect, in things staying put unless moved. But entangled particles don't respect that. They behave like two ends of a single thing, even when separated by oceans of vacuum. Some physicists believe that entanglement might be more than a quantum curiosity, that it could be the thread stitching together the very structure of space and time. That gravity, geometry, even the shape of the universe could emerge from networks of entangled particles, woven together in ways we don't yet see. It's as if, beneath all the distances and stars and time delays, there is a deeper fabric, a kind of quiet connectedness so complete that nothing is ever truly alone. That's what entanglement whispers. Not go faster, not skip ahead, but you're still part of everything. And maybe that's why it stays with you, even after the explanation fades, because it doesn't promise movement. It offers something softer, unity. So tonight, as you lie still, you can imagine that connection stretching through the darkness, not like a wire or a beam, but like a feeling, quiet, delicate, real. A thread between you and the past, between you and someone far away, between your breath and the stars overhead. No travel required, no speed to break, just the knowing that everything, somehow, is still in conversation with everything else. Let that be enough. You don't need to go anywhere tonight. You don't need to outrun time or send signals across galaxies. You only need to feel the connection that's already there. Let it settle around you like warm air. Let it hold your thoughts without asking anything in return, because you are already part of the pattern, already linked, already here, and here is more than enough. There's a rhythm to things now, a kind of slow breathing built, not from lungs or clocks, but from thoughts unfolding at their own pace. No rush, no pressure, just the gentle realization that you've been moving all along, even without motion. But now the journey shifts again, not to speed, but to something stranger, the universe itself, expanding. You've heard that the universe is growing, but what does that actually mean? It's not like dots floating apart in empty space. It's more subtle. Space itself is stretching, not a wind pushing galaxies away from each other, but the space between them unfolding, like dough rising quietly in a warm oven. Even galaxies at rest from one another are being carried apart by this silent expansion. And here's the strange part. This expansion isn't bound by the speed of light. It's not that galaxies are moving through space faster than light, it's that space itself is growing, and there's no speed limit on that. There never was. The laws of physics say you can't move through space-time faster than light, but they don't say space-time can't stretch itself faster than light can keep up. So, while your spaceship might forever be limited by that stubborn number 299,792,458 meters per second, space is under no such constraint. The fabric can stretch faster than any photon can travel, and out there, beyond the reach of any telescope, lie galaxies whose light will never reach us. Not because they're too far, but because the space between is expanding too fast. Their signals are being carried away faster than they can approach. That's why the observable universe has a boundary. Not because it's a wall, but because beyond a certain point, light simply can't make it here. Not now, not ever. It's a quiet kind of horizon, one that's always moving, always drifting farther as space expands. And it's humbling to know that the universe is not just big, but getting bigger in ways that aren't intuitive, in directions we can't even point to. It isn't expanding into anything. It's creating more within itself. At first that might sound lonely. Galaxies slipping away, light fading into unreachable silence. But it also reveals something gentle about the nature of reality, that distance is not always separation, that even what we cannot see is still connected, still part of a greater unfolding. And more than that, it reminds you that the universe isn't static. It breathes, it moves, it evolves. What you see in the night sky isn't permanent. It's a single frame in a cosmic film that plays far too slowly for you to watch in real time. But it's playing, always. Even the stars you gaze at, some of them no longer exist. Their light is still on the way, and others are being born now, wrapped in dust clouds you'll never see through, their futures still unwritten. Light is running toward you from the past, and running ahead of you into the future, and you are resting in between. And within all this swelling space, this quiet drift, you are perfectly still. Not because you're not moving, but because you are moving with everything else. Earth, sun, galaxy, all caught in the slow current of cosmic expansion. There is no fixed point, no center. Every place is moving away from every other, and so no one place is special. And somehow, that makes you more special, because to be aware of that motion, to sense the quiet stretching of reality itself, is to participate in it, not just as matter, but as meaning. You are not separate from this story. You are part of the unfolding, part of the space that stretches, part of the light that travels, part of the silence that holds it all. You may never reach the edges. You may never catch a galaxy as it slips beyond the horizon, but you can know it's there, and that knowing is a kind of arrival. So tonight, as your breath slows and your thoughts dim, you can rest in the gentle truth that you don't need to move to be part of movement. You don't need to travel to be part of the journey. You are already riding the expansion of the universe, carried gently by the growth of everything. Let that movement hold you. Let it carry your thoughts like leaves on a still river. No resistance, no effort, just quiet drift through something infinitely wide and always growing. By now, the stars don't feel like distant points anymore. They feel like quiet reminders, soft sparks of memory that light, space, and time are always moving, always changing, even when everything feels still. You've drifted so far tonight that distance has started to lose its usual meaning. But somewhere, gently, a new thought begins to unfold. If the universe is expanding, how far can we actually see? It's a simple question with a surprisingly complex answer. Because in a universe with a finite age, you might think there would be a clear edge, just draw a circle around the farthest light that's had time to reach us. But the truth is, the universe isn't just expanding, it's been doing so the entire time that light has been traveling. When we look into space, we're looking into the past. The light from the sun takes 8 minutes to reach your face. From the nearest star, it takes over 4 years. And from the edge of the observable universe, it's taken more than 13 billion years. That's what we call the look-back distance, how long the light has been on its way. But here's the twist. While that light has been traveling toward you, the space it crossed has been expanding, stretching, and that means the object that emitted that light isn't just 13 billion light years away. It's much farther now. So the actual edge of what we can observe isn't 13 billion light years out, it's more like 46 billion. That's right. The observable universe, our bubble of visibility, is a sphere about 92 billion light years wide, and yet the universe itself might be infinitely bigger than that. We don't know. We might be seeing only a tiny part of a much vaster whole. This observable part is all we can interact with, not because it's special, but because light from beyond it hasn't had time to reach us ever. That light is still traveling, still trying to catch up, but the space between is growing too fast. It's like a race where the track stretches as you run. No matter how fast light moves, the finish line keeps pulling away. And that means something quiet and profound. There are regions of the universe that are forever out of reach. Galaxies whose light will never touch us. Not now, not ever. They exist. They move. They shine. But they are already beyond our cosmic horizon. It's not sad, though. Not really. It just reminds you of how large everything is. Not large in a cold, empty way, but in a soft, expansive one. The kind of largeness that doesn't ask you to conquer it. It just asks you to wonder. Because every time you look up, you are seeing into deep time. You are receiving messages from stars long gone, galaxies long silent, events that happened before Earth had oceans. The night sky is a museum of ancient light, and you quiet, resting, dreaming are its only visitor in this moment. You don't need a telescope to witness it. You're witnessing it now. The light has already arrived. And it's not just what you see, it's what it means. That even across impossible distances, connection is possible. That even light from the edge of everything can find its way here, to your eyes, to this moment. So if you've ever felt far away from something you love, a place, a person, a version of yourself, to remember that distance doesn't always mean disconnection. Sometimes it just means the light hasn't arrived yet, but it's on the way. That's what the observable universe teaches us. That even though there are limits to what we can see, what we can touch, what we can know, within those limits lies a whole sky of meaning, a deep, slow unfolding, and we're not outside of it. We're inside it, held gently by it. You don't have to reach the edge tonight. You're already at the center of your own sky. You're already part of the unfolding. And as the universe continues to expand, so do your thoughts, quietly, naturally, without needing to go anywhere at all. Just stay here. Let the darkness be full, not of emptiness, but of quiet movement. Let the stars be ancient voices that still know your name. And let yourself feel small, in the best possible way, held by something so vast it doesn't need to hurry, and neither do you. The light is still coming. The universe was once smaller, unimaginably so. In the beginning, it was compressed into a state so dense and hot that even time itself seemed to pause. Then, in a burst beyond imagination, it began to expand, an event we call the Big Bang. But what followed was stranger than most stories can hold, a phase called cosmic inflation, where the universe grew faster than light itself. This expansion wasn't about objects moving through space. Instead, space itself stretched, doubling, tripling, and inflating at an impossible speed. The fabric of reality ballooned, carrying everything with it. No spaceship, no beam of light could have matched this pace. It was a swelling of the cosmos itself. Imagine the universe like a loaf of raisin bread, baking in the oven. As the dough rises, the raisins move away from each other, not because they're walking, but because the bread around them grows. The farther apart the raisins, the faster they seem to drift away. This is similar to what happened during inflation, but at speeds far beyond light. Cosmic inflation smoothed out the wrinkles of the early universe, setting the stage for galaxies, stars, and planets. It seeded the structure of everything we see now, and it happened so quickly and so thoroughly that the universe is still carrying the echoes of that first expansion. But here's what's beautiful. During inflation, the universe broke no rules. It didn't send signals faster than light. It didn't travel through space faster than light. Instead, it reshaped space itself. The speed limit applied to movement within space, not to the growth of space itself. This reminds you that speed isn't always about racing forward. Sometimes it's about the quiet transformation of the ground beneath your feet. And it invites a deeper reflection. If the universe can expand faster than light, then what else can it do? What other mysteries hide in the folds of space-time? What future transformations might we one day glimpse? You rest now, gently, floating in this vast, expanding cosmos of thought. The echoes of the earliest moments surround you like a warm breeze. And though you cannot see the inflation itself, you feel its presence in the vastness around you, in the slow drift of galaxies, in the quiet pull of gravity, in the light that takes billions of years to reach your eyes. Tonight, you're wrapped in that ancient expansion, carried not by engines or wings, but by the subtle stretching of space and time. You don't have to move faster than light, because the universe itself is moving with you in a dance that began at the very beginning. And as you breathe softly, you realize that this dance is not just cosmic, it's personal. It's the rhythm of your thoughts, the expansion of your mind, the gentle unfolding of dreams. Rest here, in the space between stars and ideas. Let the universe's earliest song lull you. You are part of this story, even when you're still, even when you're quiet. And in that stillness, everything moves. The universe stretches around you like a vast ocean, currents of unseen waves carrying everything gently onward. But tonight, your thoughts drift not through space, but with space riding the silent flow of expansion itself. You imagine what it would be like not to move through space, but to move with space, carried effortlessly by its slow unfolding. Imagine you're a leaf resting on a river. You don't paddle, you don't swim, you simply float, held by the current. The river moves you, guides you, whispers you forward. You feel the pull, but you don't struggle. You become part of the flow. Could a ship, a traveler, move this way? Could it surf the expansion of the universe itself, letting space do the work? Not breaking the speed limit, but slipping along a wave that carries it faster than any engine could push. It's a beautiful thought, one that bends the rules without breaking them. Instead of fighting space, you flow with it. Instead of racing, you drift, not by force, but by grace. This idea isn't just poetic. Some physicists suggest that future technologies might harness the properties of space itself. Instead of accelerating beyond light speed, a spacecraft might enter a region of expanding space, carried along like a passenger in a cosmic tide. It's not travel as we know it. It's more like surrender. like letting go of the need to control and trusting the universe to carry you where you need to go. And that feels fitting tonight, because you don't need to rush. You don't need to break boundaries or outpace time. You only need to rest in the flow. There's a calm in that surrender, a release of effort, a soft acceptance of being carried. Your breath slows, your heartbeat quiets, your mind drifts with the current of expanding space. And in that drift, you realize something profound. Movement doesn't always mean speed. Sometimes it means presence. Sometimes it means being part of something greater without forcing the pace. So let yourself float. Let the universe expand inside and around you. Let the silent river carry your thoughts gently toward distant horizons. You're already moving, just not the way you expected. Late in the gentle hush of your mind, a curious question arrives without fanfare, like a whisper carried on the breeze. If nothing can move faster than light, might information itself slip through unseen cracks in space-time, carrying messages from tomorrow into today? It feels strange, even a little daring, to imagine that you could send a thought back into your own past, an echo of wisdom or warning that arrives just in time to change a choice. Yet, in the depths of quantum theory, some interpretations allow for just such retrocausality, a subtle suggestion that cause and effect might dance in both directions, weaving a tapestry where the future and the past embrace in a silent conversation. You've already encountered entangled particles, spooky twins that reflect one another's state instantly across unimaginable distances, and you know they cannot be used to transmit controlled messages. Retrocausality is similar. Experiments hint that measurements performed on particles might influence events that preceded them, but only in random, uncontrollable ways. No one has yet bottled this phenomenon to send a clear headline back through time. Instead, it remains a gentle shimmer at the edges of possibility, suggesting that time's arrow may not be as rigid as our everyday experience implies. Scientists still debate whether these backward ripples truly exist, or if they are artifacts of our interpretations, an open question that humbles even the brightest minds. Imagine, though, that you could slip a note to yourself before you woke, reminding yourself to breathe more deeply, to choose patience over haste. It would feel like a gift. You'd awaken with a trace of foresight, a soft nudge born of your own future self. Yet if you acted on that note and changed your choice, who then would have written it? You see the paradox blooming, action influencing its own cause. The universe seems to resist such loops, preserving consistency in ways we do not fully understand. Some physicists invoke principles like Novikov's self-consistency, proposing that even if backward influence were possible, events would conspire to prevent contradictions, guiding timelines toward harmony rather than chaos. Still, the mere notion that the future might whisper into the past invites a kind of awe that turns your mind into a place of gentle wonder. It softens the boundary you thought you knew between what has been and what will be. Instead of a one-way street, time becomes a quiet river with hidden eddies, where swirls of possibility linger in moments you've already lived. It suggests that memory and anticipation might be two sides of the same coin, each informing the other in ways that transcend ordinary rhythm. If retrocausality remains beyond reach, even as a thought experiment, it enriches the heart. You realize that messages need not travel on beams of light to matter. They travel in intention, in hope, in the delicate language of human connection. A letter you write today for tomorrow's you, words you share now with someone far away, each carries forward, shaping futures that are both imagined and real. And perhaps, in some poetic sense, these intangible messages are already bending time in their own quiet fashion. As you settle deeper into this hush, you sense how thoughts can become gentle bridges, linking who you were with who you may become. You think of a comforting voice reading a bedtime story. The storyteller shares truths gleaned from lived experience, and you receive them in trust, as if they arrived before they were spoken. That, in itself, is a kind of retrocausality, a soft echo that travels from one heart to another, crossing the boundary between past comfort and present calm. Scientists still debate whether retrocausality is real physics or mere mathematical mirage. They design ever more delicate experiments, sending photons through labyrinths of beam splitters and detectors, watching for anomalies that might betray a backward whisper. So far, the results align with causality. No clear messages from the future have been captured, yet each null result deepens our understanding, teaching that nature's consistency is as profound as its mysteries. And in that balance between what we can test and what we can only feel lies the gentle magic of inquiry itself. Tonight, you rest in that space between knowledge and wonder, letting the question of retrocausality settle like stardust in your mind. You don't need to send or receive secret messages. You only need to sense that time, like space, is more alive than it appears. It breathes with you in every moment, carrying echoes of memory and anticipation in its gentle flow. And as you drift towards sleep, you carry with you the quiet assurance that connection transcends speed limits and paradoxes. Messages need no vehicle faster than the heart's own beat. They travel in the kindness of a thought, the warmth of intention, the resonance of understanding that passes between minds. You may not slip notes to your past or future self, nor intercept cosmic telegrams from tomorrow, but you do carry the potential to shape what comes next by every choice you make here, tonight. So let your breath soften into its deepest rhythm. Let your thoughts fold back upon themselves like waves returning to the sea. And let the idea of retrocausality remain a soft echo at the edge of your dreams, a reminder that time is both a gift and a canvas, waiting for your quiet brushstrokes. You are not alone in this timeless web. Every memory and hope, every lesson and dream weaves together in a tapestry that stretches beyond the horizon of light. Rest now, knowing that the gentle hum of time carries you safely forward into any tomorrow you imagine, even as you sleep. In the hush, after exploring time's pliable edges, you find yourself drawn to a more profound wonder, nature's silent aversion to paradox. It's as if the cosmos, having flirted with visions of wormholes and tachyons and retrocausal whispers, quietly recoils at scenarios where logic loops back on itself. Imagine a universe where you travel back in time to meet your younger self, hand him a note warning against a misstep only to discover he never reads it, because you'd altered the very chain of events that led you to write it. That self-defeating twist is the archetypal grandfather paradox, a tale physicists and storytellers return to again and again. Its power lies in its simplicity. Break causality, and the narrative of reality unravels into chaos. This is why many scientists suspect the universe has built-in fail-safes principles that banish paradoxes, rather than correcting them after the fact. One such proposal is Novikov's self-consistency principle, which suggests that if time travel or faster-than-light communication ever became possible, events would conspire to prevent contradictions. You might plan to save a friend by sending a message to yesterday, but somehow the message never arrives in time. Perhaps the postal service loses it, or you forget to mail it, or the universe gently steers it off course. The result is a subtle safeguard. Even if the mechanism of time travel exists, the outcome can never violate consistency. Cause may bend, but it cannot break. It feels comforting, like a cosmic umpire quietly ensuring the game can continue. Without such a rule, reality would splinter into multiple, conflicting versions of history. One timeline where your warning prevents disaster, another where it causes the very calamity you meant to avoid, and yet another where nothing matters because every possibility simultaneously unfolds and cancels itself out. That degree of fragmentation, an endless hall of mirrors reflecting infinite what-ifs, would destroy meaning. A choice would cease to matter because every choice would be made. So perhaps that's why paradoxes remain theoretical ghosts. The mathematics of general relativity and quantum mechanics allow strange solutions, closed time-like curves, algebraic loops in space-time that permit travel into the past. Yet these same equations, when scrutinized for stability, often yield infinities or event horizons that block access. In other words, the door to paradox opens in the ink of theory, only to slam shut when you push against it. Science gently reminds us there may be wonders in the equations, but they're tempered by barriers we've yet to fully understand. Even Stephen Hawking, ever the provocateur, invoked a chronology protection conjecture, proposing that the laws of physics prevent macroscopic time machines from forming. It's as if the universe edits its own story, removing pages that threaten coherence. You can glimpse the outline of a time loop in your imagination, but the actual path is blocked by infinities, quantum fluctuations, or energy conditions that crumble under scrutiny. No stable wormhole stays open long enough for a paradoxical journey. No warp bubble carries messages back. The cosmic scriptwriter insists on keeping narratives logical. And when you consider why the cosmos might enforce such consistency, it becomes more than a matter of technicalities. It's about preserving the very idea of history and memory. You, sitting quietly in the darkness, rely on cause and effect to stitch together identity. Your memories, your expectations, your sense of continuity all depend on the arrow of time pointing forward. Without that, there is no you, only a kaleidoscope of possibilities flickering in every direction. Yet paradoxes persist as thought experiments, precisely because they reveal the boundaries of understanding. They remind you that, although nature feels orderly, our descriptions of it are incomplete. You can peer into the mathematics and find the seeds of temporal loops, but you can't plant them in reality. That gap between imagination and implementation humbles you. It tells you that the universe is not merely a blank canvas for fancy ideas, it's a living system with its own priorities. So tonight, embrace that boundary as part of the wonder. You don't need to rewrite history to appreciate its flow. You don't need to send messages back to taste the sweetness of second chances. Instead, you can savor the simple truth that every moment follows the one before, weaving a coherent tapestry that you inhabit. When you reflect on a paradox, let it expand your mind rather than fracture your belief in order. Let it remind you that some questions point not to loopholes, but to deeper harmonies in the laws that govern reality. As you lie there, grounded by the steadiness of breath and the gentle procession of thoughts, take comfort in the fact that the universe preserves its own logic. It doesn't fear mystery. It simply resists contradiction, and paradoxes, as intriguing as they are, remain delicate invitations to think, not commands to change the past. They teach respect for the rules that let wonders arise without collapsing into incoherence. One day, perhaps, you'll glimpse a principle more fundamental than self-consistency, a law weaving quantum stitches to keep space-time seamless. But for now, you can rest in the quiet certainty that the cosmic narrative continues unbroken, unfolding, and always moving forward. Your story, too, drifts gently in that current, each breath a punctuation mark in the grand tale. Tomorrow will arrive because today happened. The next idea will blossom because the last one took root. And bedtimes, like ours, mark another moment in an unbroken line. You don't need to defy paradox. You only need to trust that beyond the edge of your imagination, the universe holds its plot together and invites you to dream along with it. You've journeyed through light and space, drifted inside imagined bubbles, and glimpsed tunnels through time. Yet here, in the gentle hush, a different marvel unfolds. Gravity's quiet power to reshape space itself. Light, which travels straight until it meets mass, bends its path around massive objects, a phenomenon known as gravitational lensing. When starlight passes near a galaxy cluster, it can arc, magnify, or even form rings of light, called Einstein rings, as if the universe itself is peering through a cosmic magnifying glass. This isn't fantasy. It's been observed in countless galaxies, and astronomers use it to study dark matter and distant objects that would otherwise remain hidden. Imagine standing beside a calm pond and dropping a pebble. Ripples spread outward, curving and reflecting the world's image in soft distortions. Gravity does something similar in space-time. Mass creates a dip in the pond of reality, and light's ripples follow those curves. A star's gravity can bend light as it skirts the star's edge, an effect first confirmed during a solar eclipse in 1919, when starlight near the sun appeared shifted. That bold experiment proved Einstein right and revealed an odd but beautiful fact. During totality, starlight passing just 700,000 kilometers from the Sun bends by about 1.75 arcseconds, roughly the width of a dime seen from 2 miles away. Today, sophisticated telescopes detect gravitational lensing across the cosmos, allowing us to map invisible matter in clusters hundreds of millions of light-years distant. Yet beyond its scientific utility, gravitational lensing holds a quiet emotional resonance. Consider how memories can warp in the mind, curving around painful truths or magnifying moments of joy. Just as light's straight journey curves when it encounters mass, your thoughts bend in the presence of experience, distorted, refracted, sometimes forming beautiful patterns you didn't expect. In life, small events like the pebble in a pond can send ripples through your consciousness, altering the shape of your personal universe. Scientists still debate whether gravitational lenses could ever be harnessed for communication or travel, an open question, inviting both caution and wonder. Could a sufficiently massive object act as a bridge or telescope, bringing faraway regions into view? Some theorists have toyed with the idea of gravitational telescopes that use galaxy clusters to magnify ancient light, giving us glimpses of the universe's infancy. Yet the same mass that magnifies can trap light forever, creating black hole shadows where not even light escapes. This paradox reveals how gravity's dual nature, gentle bending versus inescapable pull, shapes reality with subtlety and force in equal measure. Emotionally, lensing reminds us that perspective is everything. A distant foe may seem menacing until you see them through a different lens. A forgotten memory can reappear, magnified and transformed when viewed from a new angle. Just as gravitational fields surround massive bodies like invisible sculptures, your own experiences build fields of feeling around your heart, bending light and memory in unique patterns. You are both observer and participant in this interplay, seeing the world directly yet always through the curves shaped by your history. Beyond galaxies, lensing also highlights an odd cosmic coincidence. Some gravitational lenses magnify supernovae known as standard candles, enabling astronomers to measure cosmic expansion with extraordinary precision. In 2014, a supernova in galaxy cluster MAX J 1149 plus 2223 was seen as multiple images, arriving at Earth days apart due to different paths around the cluster's mass. This fleeting event provided two natural telescopes in one, a chance to measure Hubble's constant in a novel way. Yet even as we celebrate these breakthroughs, debates continue. Different measurement methods yield slightly divergent values for cosmic expansion, leading to the Hubble tension. Scientists still debate whether this tension hints at new physics or reveals hidden errors in our models. In your own life, you might sense a similar tension between expectation and reality, an echo of Hubble's puzzle in your personal horizon. Perhaps a plan unfolds more slowly than you hoped, or a relationship bends in unexpected directions. Yet these nuances, like gravitational distortions, can bring unexpected clarity. Bending brings focus, even when it feels like chaos. The bending of space-time doesn't erase history, it reveals deeper layers, showing that what appears straight may in fact be a gentle arc shaped by unseen influences. As you drift between wakefulness and sleep, let this image comfort you. Your mind, like space-time, is flexible. It can bend under the weight of mass memories, emotions, experiences, and still guide light your awareness toward new horizons. You need not fight gravity's tug. You can surrender to its contours, allowing your thoughts to flow along the curves it creates. In this way, relaxation becomes a form of lensing, refracting tension into peace, magnifying moments of calm until they encompass your entire being. Remember that even the strongest light, your boldest hopes, must follow the curve of reality. It cannot escape the landscapes shaped by gravity, but it can illuminate them with grace. And sometimes, the most profound insight arrives not from speeding ahead, but from bending toward the influences that shape us. Just as distant galaxies reveal themselves through lensing, your own depths unfold when you welcome the gentle curvatures within your heart. Tonight, you rest in a universe that bends without breaking, where light and gravity dance in harmony. You are both the lens and the light, the observer and the observed. Let this thought carry you deeper into sleep, cradled by the subtle shaping of space-time and the tender contours of your mind. You drift in a calm, no longer defined by engines or waves, but by the soft thrum of imagination. And suddenly you picture something impossible, a ship moving faster than light, not carried by bubbles or bends, but simply passing beyond the cosmic speed limit. What would that even look like? Would it glow like a comet? Would the stars warp around it, trailing and looping in an impossible dance? How could your senses make sense of something that breaks the rules by which they measure reality? To begin, imagine the familiar, a contrail of exhaust, the sudden flash of metal against a dark sky, the roar of acceleration. Now erase all of that. In relativity, nothing with mass can reach the speed of light, and for a moment, you forget mass altogether. You see a blur of light, a disturbance in the fabric of space-time rather than a vessel. As the ship surpasses light speed, the light emitted from its surfaces would never overtake you. It would stretch, smear, and compress, forming a streaming ribbon of Doppler-shifted colors from deep red to fierce violet, so extreme that the visible spectrum would collapse into a single, shifting hue. And what of the background stars? Normally starlight flows past you steadily, but here it would fold. Light from stars behind you would be blue-shifted, compressed into brilliant points. Light ahead of you would be stretched into infrared or radio waves, invisible to the eye. The ship's passage would carve a cone of altered starlight, an optical shockwave akin to a sonic boom in air, but in this case, a luminal boom. The trail you see would not be fire or plasma, but a boundary between normal space-time and the superluminal region where the ship has already passed. It would shimmer with Cherenkov-like radiation, a ghostly blue glow emitted when charged particles outrun light in a medium, here taking place in the fabric of space itself. From your vantage point, you might see the ship arrive before you ever knew it had left. It would appear without warning, a sudden Einsteinian ghost, suspended at the event horizon of causality. If you watched its departure, you would see it vanish into a point of infinite Doppler shift, a winking star that disappears by redshifting beyond detection. The effect would be disorienting and almost lyrical, starlight refracting, reframing, reflecting in impossible directions, looping you into glimpses of places you have not yet visited. And yet, the ship itself would not be a solid object as you know it. Observers inside would see the universe compressed in front of them, the distance to every star folded into a narrow band of light. To them, the journey is instantaneous, no time elapses between departure and arrival. But to an outside observer, the ship would distort the sky like a hall of mirrors, bending views backward and forward, showing you snippets of emerging worlds and industries as the light from each region momentarily catches up. Emotionally, the vision feels like longing brought to life. You know what it's like to wish you could arrive before you've even begun, to touch a moment before it's written. This ship embodies that yearning and architecture of desire that defies weight and distance. Yet it also carries a warning. The vessel's path would tear at the seamless tapestry of cause and effect, leaving behind ripples that might echo backward into time itself. Each glimpse you catch of its voyage would be both future and past, a reminder that speed alone cannot conquer the order of things. No one has ever seen such a passage, of course. The equations forbid it for any object with mass. But in your mind's sky, it is a fireworks display of possibilities, shimmering shockwaves, fractured starlight, a halo of impossible color. It reminds you that what we see is bound by what can reach us, and anything faster would rewrite the script of perception. A ship like this would be invisible to conventional sight until it arrived, and then invisible again from where it slipped away, its story told only in the brief, distorted gleam it leaves behind. Perhaps the most haunting image is the afterglow, the starfield settling back into its pattern as if someone gently shook a snow globe and then set it down. The data stream of altered wavelengths retreats, the Cherenkov echo fades, and all returns to normal until the next superluminal dream. In that return, you sense something profound. Rules exist to preserve coherence, to keep the universe intelligible. Without them, every horizon would blur, and every history might rewrite itself. So you exhale, releasing the imagined glow and allowing the familiar night to reclaim your thoughts. The stars resume their ancient, measured rhythms. No ship glides between them, no warp bubble shifts the sky, and yet the memory of the vision lingers like phosphorescence on your eyelids. It reminds you that though the universe may guard its speed limit, it also opens its secrets to the curious and the dreamers. In this gentle realization, you find comfort. You don't need to see a faster-than-light ship to feel its wonder. You only need to appreciate the light that already surrounds you, traveling faithfully at its own perfect pace. The true voyage lies not in outrunning photons, but in following their steady journey across space and time, knowing that every beam of starlight has its own story, one you can witness tonight as you drift towards sleep. By now, you may have noticed that faster-than-light travel, warp bubbles, wormholes, tachyons, and retrocausal whispers all share something unexpected. They're not just scientific curiosities, but reflections of our deepest yearnings. They arise not because we need to outrun photons for practicality, but because we long for connection, for closeness, and for meaning beyond the limits imposed by distance and time. That yearning is as old as storytelling itself. Humans huddled around. Fires have always dreamt of bridging oceans, visiting distant lands, or hearing a friend's voice across mountains. In those ancient tales, the barrier of separation was often symbolic, representing not only geography, but also the gaps between hearts, the chasms carved by fear or misunderstanding. What makes faster-than-light travel so compelling is that it literalizes this symbolic barrier, turning psychological desire into a physics problem. If only we could push past the cosmic speed limit, we could collapse separation itself. And yet, even as we imagine ships slipping quietly beyond light speed or messages slipping backward through time, there is another truth at play. The boundaries we confront are not just external, they are woven into our very nature. We age, we change, we forget, we hope. Our brains are limited by perception, our bodies by biology, our dreams by memory. When we long for FTL travel, perhaps we're yearning not merely for distance to shrink, but for the parts of ourselves we can't reach, lost moments, unspoken words, versions of the self left behind. Faster travel becomes an embodiment of nostalgia and aspiration intertwined. We imagine arriving before we've left, revisiting our own pasts as if to reclaim a piece of ourselves, or jumping ahead to glimpse possibilities yet unrealized. In this sense, bending space-time isn't only about rockets or equations, it's about the human impulse to transcend limitation, to make the intangible love, understanding, presence into something tangible. But every boundary contains a gift. The cosmic speed limit protects causality and coherence. It preserves the meaningful sequence of events that let us construct narratives personal, interpersonal, historical, and imbue actions with intention and value. Without that sequence, choices would dissolve into randomness, memory into confusion, identity into fragmentation. The things that make life feel real and cohesive cause and effect. Before and after, intention and consequence would unravel. And so, as tempting as it is to dream of outrunning light, there's wisdom in recognizing that some limits are not prisons but the frames that hold our experience in focus. In your own life, you've probably felt the tension between rushing forward and staying present, between leaping ahead and savoring what's here. Faster-than-light travel is a cosmic metaphor for that tension writ large. It asks, do you want to arrive, or do you want to journey? When you chase a goal, you risk missing the small moments that give each step its meaning. The smile of a friend, the warmth of sunlight through leaves, the quiet calm of a breath. And when you slow down enough to notice, you discover that presence itself is a kind of superluminal gift. It transcends the frantic push of desire by collapsing the distance between your mind and your moment. You're not physically closer to the stars, but you're closer to your own sense of wonder. This is the subtle lesson behind all our exotic dreams, that longing, curiosity, and imagination can carry us farther than any ship. We can't touch Alpha Centauri overnight, but we can inhabit its landscapes in our minds, in our art, in our relationships. Stories, music, letters, memories, they travel faster than light in their own way, slipping through walls, across languages, into hearts. The letters your past self wrote to your future self, the songs you associate with specific moments, the photographs that bring you instantly back in time, all of these are forms of information that circumvent physical distance. They remind you that connection is not only a matter of speed, but of empathy, creativity, and shared humanity. So tonight, as you drift between wakefulness and dreams, let the thought of faster-than-light travel settle into something gentler, a metaphor for your own journey through memories and hopes. Let it remind you that the real voyage is inward as much as it is outward. You may never pilot an Alcubierre bubble or glimpse a wormhole's twin exit, but you can bend the space between you and another person with understanding and kindness. You can bridge the gap between what was and what could be with forgiveness and intention. You can fold the blanket of your life so that distant memories and future possibilities lie side by side, accessible in the quiet space of reflection. And perhaps that is the most profound travel of all, the ability to fold time and space with your mind, to weave past, present, and future into a tapestry that holds every thread in view. In this gentle motion, you find freedom not from the rules of physics, but from the boundaries of fear, regret, loneliness, and doubt. You discover that connection, creativity, and compassion are not limited by speed. They are qualities that flourish in stillness and presence. So let the night embrace you. Let your thoughts stretch across the universe of your own experience. Feel how each breath bridges the gap between then and now, between longing and fulfillment. And know that while the stars may remain distant, your heart can touch them anytime you choose. Rest now, carried not by warp bubbles or tachyon beams, but by the quiet geometry of your own curiosity and care. For in that space, you have already traveled faster than light. As the journey unspools to its final scene, you realize something tender. You haven't flown faster than light, yet you've traveled farther than any rocket could reach. Your mind has navigated cosmic horizons, folded space and time, and dwelled in paradox without breaking a rule. You've ridden the steady drift of expansion, peered through wormholes, and listened to the quiet pulse of entangled particles, and through it all, you've discovered that true travel isn't measured in kilometers per second, but in the breadth of your wonder. Tonight, you rest in the serene center of that wonder. You are both observer and participant in a universe that remains magnificent at light speed and beyond. You've watched photons stretch into rainbows, felt the tug of warped space, and sensed the gentle tug of past and future converging in a single breath. You've learned that limits are not walls but contours that shape meaning, and that the cosmos invites you not to break its rules, but to dance with them. The same cosmos that forbids FTL travel gifts you with imagination, curiosity, and connection. It teaches that the information most precious, love, empathy, memory, moves not at 299,792,458 meters per second, but at the pace of a caring thought. You've folded the blanket of reality with your mind, drawing distant memories and hopes side by side. In that act, you've transcended distance more profoundly than any spaceship could. Now, as you sink deeper into your bed, let that realization become your lullaby. Let the knowledge that you are part of an unfolding tapestry, woven from light and gravity, memory and dream, comfort you. Let each breath remind you that you carry the universe within, a cosmos of ideas and emotions that no speed limit can contain. Rest here, enveloped by the gentle geometry of your own mind. You're not seeking to outrun light, you're learning to share its glow, and in that shared glow, you've already traveled light years tonight. Tonight's journey explored the tantalizing question, could anything surpass the cosmic speed limit set by light? Over 25 sections, we drifted through the nature of the speed of light, Einstein's relativity, time dilation, and the increasing inertia of mass. We imagined particles that outpace light, photons' timeless voyage, and warp drives that bend space itself. We glimpsed quantum effects, like negative energy in the Casimir effect, wormholes as natural shortcuts, and the paradoxes gratifying yet forbidden of retrocausality and time travel. We marveled at entanglement's spooky bonds, the universe's expansion faster than light, and gravity's subtle lensing of starlight. Each concept illuminated how limits shape possibility, revealing that the speed limit not only preserves causality, but frames meaning. Most essential was the realization that human connection, memory, empathy, imagination travels in its own geometry, folding past and future inside the heart. Though we can't physically travel faster than light, our minds traverse vast distances of wonder and warmth. The true voyage lies not in breaking physics, but in embracing its contours through curiosity and care. As you rest, know that you've journeyed farther than any starship. You've traveled within,